Hi friends, in last class we have discussed about the standards and calibration of temperature measurement. I hope you all are gone through that class. Now let's move on to next session, temperature sensing devices. It's an important topic. As we know that temperature sensing device is used to measure the temperature. As per the ways in which the temperature measurement is carried out, we can classify these temperature sensing devices into 6. That means there are 6 important ways of temperature measurement, and they are: first one, thermal expansion methods; second, thermoelectric sensors or thermocouples; third, electrical resistance sensors; fourth, junction semiconductor sensors; fifth, digital thermometers; and sixth one and last, radiation methods. Since these topics are large in contents, we can split our class again. First two topics, that is thermal expansion methods and thermoelectric sensors, will be discussed in this class, and other topics will be discussed in later. Now let's see what is thermal expansion method. As the name indicates, the expansion of suitable materials along with the change in temperature is carried out here. According to the material used for temperature measurement, we can subdivide this thermal expansion method into 3. 1. Bimetallic thermometers. This thermometer is used with the solid materials. Second one, liquid in glass thermometers. It is used with the suitable liquids. Third one, pressure thermometers. Vapor or gas is mainly used. Bimetallic thermometers. A bimetallic strip made up of metals, say A and B, is used here. Here, thermal expansion coefficient alpha plays the main role. What is thermal expansion coefficient? The rate at which a material expands with increase in temperature is called thermal expansion coefficient. The metals, say A and B, used for making bimetallic strip will have different thermal expansion coefficient, and it is obvious that the alpha value clearly depends upon the material which we are used. For high expansion, brass or nickel iron alloyed with chromium and manganese are used. If the expansion needed is low, Invar, it's an alloy of nickel and iron, is used. These metals are bonded together at same temperature. Due to different value of alpha, these metals will have deflected in different manner. If alpha value of A is greater than that of B, more deflection will be occurred for metal A. Then a circular arc will be formed as shown in this figure. From this, we get the radius of curvature, thereby the deflection, hence the temperature. Applications of bimetallic thermometers. It is best suited in the range of -70 to 540 degrees Celsius. It is used as temperature compensating device. It mainly used as cutoff switches and in air conditioning thermostats. The helix strip is used for process applications such as refineries, oil burners, etc. Now let's move on to advantages and disadvantages of bimetallic thermometers. They are very simple, robust and inexpensive. Their accuracy is in between 2 to 5%. They can withstand 50% overrange in temperatures. It's one of the very important advantage of bimetallic thermometer. And similarly, the disadvantages are, even though they are capable to work within 540 degrees Celsius, up to 400 degrees Celsius only to give a better performance. They are not recommended for temperatures above 400 degrees Celsius. When regularly used, the bimetallic may permanently deform, which in turn will introduce errors. Now, let's see the next thermometer having another thermal expansion method, to measure the temperature. It is liquid in glass thermometers. It is most commonly used device to measure temperature as it is easy to use and inexpensive. The liquid used in thermometer is mercury, and the working principle is the apparent thermal expansion of mercury. It requires special glasses and an inert gas filled in the capillary space above the mercury. It is best suited to measure temperature from -39 to 540 degrees Celsius. It is again classified as two. First one, total immersion thermometer. Second one, partial immersion thermometer. Note that accuracy is more for total immersion type. Main advantages and disadvantages of liquid in glass thermometers are: advantages: it is cheaper and easy to use. Second one, it do not need any power supply or battery. Hence it is very helpful in special situations where the power supply is not available. Third one, it has good repeatability. And the disadvantages are: it cannot provide digital automated result. And second one, manual reading is necessary, so accuracy is less. We have to read it manually, so there may be any observation errors arises while measuring the temperature. Next category of thermometers which are using thermal expansion method to measure temperature is pressure thermometers. It consists of mainly three parts: a sensitive bulb, an interconnecting capillary tube, and pressure measuring device like Borden tube, bellows or diaphragm. This system is completely filled with liquids such as mercury or xylene. Under an initial pressure, the compressibility relative to pressure gauge, that is, the ratio of change in volume with respect to change in pressure, is considerably small. Hence, it has large pressure change at constant volume. The length of capillary tube can be increased for remote measurement. Compensation methods for pressure thermometer. Except in vapor pressure type, compensation is required for temperature variations along the capillary and at the pressure sensing device. The motion of the compensating system is due to the interfering effects only and is subtracted from the total motion of the main system, which gives an output depend only on bulb temperature. Note that trimming capillary, its length can be adjusted. It is used to change the volume to get accurate compensation. Next one, thermocouples. If two wires of different materials A and B are connected in a circuit with one junction at temperature T1 and other at T2, then an infinite resistance voltmeter detects an EMF, say E. Magnitude of E depends on the materials A and B and temperatures T1 and T2. Similarly, current I can be measured using an ammeter. Actually, the thermoelectric EMF is effect uniformly distributed along the length of each single metal wire, and it exists even if the wire is not connected to anything. Its magnitude depends on the material property called absolute Seebeck coefficient and the distribution of temperature along the wire. How we can use a thermocouple to measure temperature? The relative Seebeck EMF E is listed in standard tables supplied by manufacturer of thermocouple wire. These tables set in such a way that one of the thermo junction called reference junction is at a known temperature, usually at ice point, that is at 0 degrees Celsius. Note that in every thermocouple, the temperature of one of the junctions must be known. Then only we get the temperature of other junction from voltage measurements. Now let's see what is laws of thermocouples. Mainly there are 5 laws associated with it. 1. The thermal EMF of a thermocouple with a junction at T1 and T2 is totally unaffected by temperature elsewhere in the circuit if the two metals used are each homogeneous. Second, if a third homogeneous metal, C is inserted into either A or B, as long as the two new thermojunctions are at like temperatures, the net EMF of the circuit is unchanged irrespective of the temperatures of C away from the junction. If metal C is inserted between A and B at one of the junctions, the temperature of C at any point away from the AC and BC junctions is immaterial, as long as the junctions AC and BC are both at the temperature T1, the net EMF is the same as if C were not there. Fourth one, if the thermal EMF of metal A and C is E suffix Az and that of metals B and C is E suffix Cb, then the thermal EMF of metals A and B is E suffix Az plus E suffix Cb. See the diagram. Fifth point. If a thermocouple produces EMF E1 when its junctions are at T1 and T2 and E2 when at T2 and T3, then it will produce E1 plus E2 when the junctions are at T1 and T3. Note that besides Seebeck effect, two other effects known as Peltier and Thomson effects are also coupled with thermocouples. As these effects are negligibly small, it is beyond our scope. Peltier effect is concentrated at the junction and Thomson effect is distributed along the wires. Those who are interested, please go through these links.